right, we are moving into a new chapter, chapter 4, which is called quadratics. So quadratics are any function that has an x squared in it. You'll notice everything we've done prior to this has been linear, meaning it just has an x to the first power in it. So when you're dealing with quadratics, your most basic quadratic is just x squared. So I just want to show you on your calculator what x squared looks like. So if you go to y equals on your calculator and just type in x to the second power, and hit graph. I'm going to go zoom 6 because I don't know the last thing I graphed. So this is what x squared looks like. We call this shape a parabola, and this is our most basic parabola. We often call it the parent parabola because it is the one that is centered or has a vertex, is a word you're going to hear me say a lot, at 0, 0, and it opens upwards. That's how we would describe this parabola. Basic parabola has a vertex, which means that lowest point, the bottom of the U, just like we talked about with vertex of absolute value, and it opens up. If I want to change that parabola, I could take x squared and I could add a number after it. So I could do x squared plus 3 and hit graph. And what you'll notice is that exact same parabola just shifted upwards. It moved, that 3 actually is a vertical shift. It moved it upwards. If I wanted to move it down, I could subtract 3 or subtract any number, and I would see a parabola that shifts down. If I want to move it right or left, I have to actually put in parentheses x and then a plus or a minus something. If I do like a plus 5 and square it and graph it, what that does is it takes your parabola and it shifts it to the left 5 spaces. If I want to shift it to the right, I would subtract in the parentheses 5, and that would shift it right 5 spaces. If I want to flip it upside down, I would put a negative in front of it. So I'm going to insert a negative sign right in front of it. It's going to take that parabola and it's going to flip it upside down. The other thing I can do with my parabola is I can increase how wide it is or decrease it, make it skinnier by putting numbers in front of the parentheses. So let's say I put a 4 in front of the parentheses. When I put a 4 in front of the parentheses, it's going to take that parabola and it's going to make it much more narrow. It's going to make it a skinnier graph. Anytime you put a number in front that is bigger than 1, you're going to make it narrow. If you put a number in that is smaller than 1, so let's make this 0.5, and there's 0.4 instead of 4, and graph it. It's going to take that parabola and it's going to widen it. So we will have a wider parabola than the parent function. And everything is referenced to that basic x squared. So today's lesson is focusing on what's called vertex form. Vertex form is a form of a parabola that makes it very, very easy to identify the vertex. That's why it's given that name. Vertex form is y equals a parentheses x plus or minus h squared plus or minus k. This form is going to be very, very similar to what we did with absolute values. Your vertex, which we're going to list, we call it the point hk, is going to depend on whether it moved right or left or up or down. So just to recap what we did with absolute value, if it's x plus a number, it is going to go left that many spaces. If it is x minus a number, it is going to go right that many spaces. If it's a positive k value at the end, it's going to go up that many spaces. If it's a negative k value, it's going to move downward. Finally, my A is going to talk about how does it open. So how does it open? If A is bigger than 0, it's going to open up, meaning it looks like a U. If A is less than 0, it's going to open down, meaning it looks like this, upside down. It does have a line of symmetry. That line of symmetry, we say it's symmetric about, or your axis of symmetry, will always be x equals whatever the x value is in your vertex. So if your vertex is 5, 8, your symmetry line is going to be x equals 5. It's going to be a vertical line. It's always a line that runs up and down that's going to slice that parabola into 2 equal parts. Finally, for the wider than or narrower than, if you have an a value, and we're going to ignore the negative, so we're going to look at the absolute value of that a value, because that a value, that negative is just going to flip it upside down. If we have an a value that the absolute value of it is less than 1, so like 0.5, 1/3, 2/3, that is going to be a wider graph. And if we have an a value that's bigger than 1, again, ignoring if it's negative or not, taking the absolute value. So let's say you have a 4 in front of the parentheses or a 5 or a 1.5, that is going to be a narrower graph. We can also tell if the graph has a maximum or a minimum, and that is going to be based on if it opens up or down. So if it looks like this, if it opens up, we would call this the minimum point. If it opens downward, we would call this the maximum point. And that minimum and that maximum are always going to happen at the y value of the vertex. And we'll recap that as we go through and do some example problems. So we just talked about all of that. So we're moving on. So here's going to be some questions, and it's going to ask you to describe how it moves. Does it go right or left? Does it go up or down? Does it flip? We're going to draw it. We're going to state the vertex, the axis, and if it has a maximum or a minimum value. So this first one has a negative in front. So that is going to tell me that it flips, meaning it's opening downwards. It's going to look like that. It also goes right 1 space, and it also goes down 4 spaces. So from my picture, I'm going to go right 1, down 4, and get my vertex. It's upside down. I do not care how detailed you do this graph as long as you draw it upside down. Your vertex then is going to be at the point 1, -4. Your symmetry axis, your axis of symmetry, is going to be x equals 1. That's going to be the vertical line that splits it in two. You don't have to draw it, but I do want you to understand what it's representing. And this vertex is going to be a maximum because it's the peak. And we would say the maximum happens at -4 because that's the highest it ever gets. The next one does not flip upside down. It's going to be right side up. It goes left 2, and it goes up 1. So from my picture, from my origin, I go left 2, up 1, and put a point. That's going to be my vertex. And I'm going to draw my parabola going upward this time. My vertex, I usually use a capital V for vertex. My vertex is left 2, up 1, so it ends up at -2, 1. My axis of symmetry is x equals -2. And this point this time, this vertex is a minimum. It's the lowest the graph ever gets, and the lowest it ever gets is at 1. So we would say it has a minimum value at 1. I want to show you a delta math question just so you get an idea of how this is going to be done. So here's a delta math question. So what they're going to ask you to do in delta math is the very first ones are going to ask to kind of guide you through it and saying, we're going to start with x squared. How do we get this dotted parabola? So if you look at this one, I thought this was a nice one because it had a lot of things going on with it. Just want to show you what's going to happen on your screen. So first thing I notice is my dotted one is flipped upside down. So I need to take this little box and change that to a negative. And notice when you do that, it flips it for you, which I love. Then I'm going to look and see how did I go from my vertex of my black one to the dotted one, and it looks like it goes left 3 spaces. So if it's going to go left 3 spaces, that's going to need to be a +3. And notice when I type that in, it goes left 3. If you type something in and it goes the wrong way, you just type something else in. So it'll kind of do what you ask it to do, and you can see if it's right. And then finally, it goes up. It goes up 1, 2, 3, 4 units. So I'm going to put a 4 there. And it shifts up. And if you correctly put the new parabola on the dotted one, then you will be able to submit, and you are right. So that's the focus of today's lesson. We should be able to look at any parabola that's in vertex form, and we should be able to identify the vertex, the axis of symmetry, what transformation happened, does it have a minimum or maximum, does it flip, all of those things so that I can work with these parabolas and have a good idea of what it looks like. And that's 4.1.